Welcome to lesson 14 in our interactive notes. Looking at part 1. So here we're going to be generating number and shape patterns and identifying features of patterns. It's going to be pages 35 and 36. So here, generating number and shape patterns and identifying features of patterns, our content objective for 4th grade OA, Operations in Algebraic Thinking, C5. I can create a number or shape pattern that follows a given rule and notice different features of the pattern. Language objective, I can explain and describe the creation of a pattern and identify features of the pattern. Social objective, I can work with others to create a model to show various patterns. So we have some vocabulary words here. First, pattern, the repetition of a rule to form a series of numbers, objects, etc. Shape pattern, here the rule is AB. So it goes square, circle, square, circle, square, circle. So it's an AB pattern, AB, AB. The rule, an operation that determines the next number or shape in the pattern. So if we follow this rule of AB, it'll repeat each one over and over again. This number pattern says the rule is add 8. So 8, 16, 24, 32. We're adding 8 each time in that rule. Characteristic, a basic feature, trait, quality, or property. So something that you notice about those certain things. Like here, it has some curved sides, this has flat sides. So just looking at features of it. Braces, a symbol that looks like these, which is used to group quantities into a unit or set. So if we have a set of numbers like this, we have braces on them. Here we have a set of even numbers. Term, any number in a sequence, a number or variable in an expression. So here we have a sequence 2, 4, 6, 8, 10. This is our first term, second term, third term, fourth term, fifth term. We can also call parts of an expression terms. A sequence is a list of objects or numbers in order, following one after the other. 1, 2, 3. So we have a sequence 1, 2, 3, following in a pattern in an order. Arithmetic patterns, a sequence of numbers in which the difference between any two consecutive numbers is the same. So anytime you have a rule that's add or subtract, that's called an arithmetic pattern. So here we're adding 8 each time. If we were subtracting 8 each time, then that would be called an arithmetic pattern. Corresponding terms, terms that are in the same position in a sequence of numbers. So here, add 3 is the rule, so the first term is 3, 6, 9. So the first term is 3, second term is 6, third term is 9. But if the rule is add 6, the first term is 6, second term is 12, third term is 18. In both of these sequences, our second term would be 6 and 12. So they are in the same place. They're both second terms. All right, now let's look at some patterns. We're going to look at the shape ones first, and then we're going to look at some number ones. So here, Joanna makes a pattern using block towers. The first 4 towers are shown below. So the first tower has 3. The next tower has 6. The next one has 9. The last one has 12. So those are the first, second, third, fourth towers. If she keeps following this pattern, how many blocks will be in the 12th tower? Well, if we keep adding 3, after 4, the 5th one would be 15, 5th term. 6th tower would be 18. 7th tower would be 19. 8th tower would be 20. I'm sorry, 21 would be the 7th. I got off there. 24 would be the 8th. 9th would be 27. 10th would be 30. 11th would be 33. And 12th would be 36. So another way to look at this is, since we're repeatedly adding 3 each time, and we're starting with that 3, if we take the position times 3, we can get that missing one. So 12 times 3 gives us 36. There would be 36 blocks in the 12th tower. So answering this question, how many blocks will be in the 12th tower? There will be 36 blocks in the 12th tower. So what we're doing here is we're trying to generate rules, look at patterns, come up with different rules to be able to predict what will come up in the future or later on down the line. We're looking at another pattern now. Claire makes a shape pattern. The first 6 terms are shown below. So it looks like our pattern goes triangle, square, square, triangle, square, square. And it goes 3 at a time. So 1, 2, 3, 4, 5, 6. We want to figure out what the 26th one will be. Well, if we go by 3s, so 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. This will also be the 26th one because the pattern follows in 3s. We end a pattern at 24, then we begin it at 25, 26, and end it at 27. So what will the 26th shape be in the pattern be? It will be a square. The 26th shape in the pattern will be a square. Right. So here we're trying to see what's happening to go from here to here. I could add 6 or I could multiply by 3. So from 3 to 9, from 6 to 18. If I were to add 6, I'd only get to 12, but if I multiply by 3, I get 18. 12 times 3 is 36, so it looks like our rule is multiply by 3. And if I follow this, I go 3, 6, 12. I'm just going to go ahead and put 15. 15 and 15 is 30, and another 15 is 45. 3 times 15 is 45. Now if I look, when I multiply to an odd number, I get an odd number. When I multiply 3 to an even number, I get an even number. So if I multiply an odd number to an odd number, I get an odd number. So I could put products of odd numbers are odd. To go from 70 to 50, I can only do that through subtraction, subtracting 20. So my rule is subtract 20. So 60 take away 20 is 40. What take away 20 would be 30? Well, that would be 50. 40 take away 20 is 20. Is there anything else we can notice? Other patterns? Maybe that the numbers are going down or decreasing. We just want to look and see, is there something we notice within the pattern? There can be more than one thing. There's not just one right answer to what you notice. Here, 2 to get 1, I can either subtract 2 or divide by 2. I'm sorry, subtract 1 or divide by 2. Let's see, if I subtract 1, I'd get 3, but if I divide by 2, I get 2. So it looks like the rule is divide by 2. So what would I divide by 2 to get 5? Well, 10 divided by 2 is 5. 20 divided by 2 is 10. Is there something that we notice? The B numbers, because this is in column B, is half the value. So another way of saying divide by 2 is finding half. Okay, so now we're going to look at some more number patterns. Here we're told a rule. We're going to start at 5, so I know what I'm going to start with. And I'm going to add 8. 5 plus 8 is 13. Plus 8 is 21. Plus 8 is 29. Plus 8 is 37. Plus 8 is 45. What is something that you noticed about this pattern? Well, it's kind of interesting that what I have going on here is that they're all odd numbers. When I started with an odd number and adding an even number each time, they stayed odd. All of the numbers in the sequence are odd, and I would predict that that will continue. So something that I notice, they are all odd numbers. Next we have another rule. It says to start at 1 and add 3. So start at 1, add 3, I get 4. Add 3, I get 7. I add 3, I get 10. I add 3, I get 13. Add 3, I get 16. So when I started with an odd number and added even number each time, they all stayed odd. This time I started with an odd number. Adding an odd number, it became even. Adding an odd number, it was odd. Even, odd, even. So it's interesting that something I notice in this pattern is they alternate or change back and forth. Odd and even. Okay, so we have a couple more problems here. 3 more. Ruth wrote a pattern with the rule subtract 5. She started at 77. Will the number 30 be in her pattern? Explain your answer. So if I start with 77 and I subtract 5, I get 72. Subtract 5, 67, 62, 57, 52, 47, 42, 37, 32. Am I going to get 30 in that list if I continue? No, because here it's the same idea as, is it a 5 a factor? Well, it only is a factor if it ends in 0 or 5. There's not going to be a 0 here. It's only going to be a 2 or a 7, a 2 or a 7 in that one's place. So no, 30 will not be in the pattern. Because the ones place is always a 7 or a 2, not a 0. Next one. Spencer sets up 8 rows of chair. He puts 4 rows in the first row. 4 chairs in the first row, 8 chairs in the second row. So in 8 rows, 4, 8, 12 in the third row, and so on. How many total chairs does Spencer put into rows? Well, the first one would be 4. So our first row is 4. The second row is 8. The third row is 12. If we keep following this pattern, the fourth row will be 16. The fifth row would be 20. The sixth row would be 24. The seventh row would be 28. And the eighth row would be 32. So we add all these numbers together, and there's actually a couple of neat little ways of doing that. Finding, like 8 plus 12 is 20, 4 plus 16 is 20, so we have 20, 40, 60. Then we have 20 more. 80 plus 10, 90 plus 30, 120 plus 24 is 144. Another trick is something that a famous mathematician named Gauss, when he was a 4th grader, discovered. You add these two together, you get 36. You add these together, 36, 36, 36. So he figured out he could just do 4 times 36 and get the answer. Well, 4 times 36 is 144. So someone your age actually figured out that pattern with sequences. So how many did he put into rows? Spencer put 144 chairs into rows. Last one. Peter writes a pattern with the rule add 12. If he starts on any even number, will any of the terms be odd? Explain. So any even number. I'm going to start with the lowest even number just to see what happens. 2 plus 12 is 14. 26, 38. That would continue. So far in that pattern, they're all even. Let's see what would happen with 8. Because 8 plus 12 is 20, 32, 44. Does it look like any of those are going to be odd, or are they going to keep being even? They will keep being even. When you add an even number to an even number, the result will be even. If Peter starts on an even number, all the terms will be even. Now, let's see what happens if you have an odd number. 1 plus 12 is 13, so we get an odd number. Plus 12 is 25, we get an odd number. Plus 12 is 37, we get an odd number. What about 3? 3 plus 12 is 15, 27, 39. So the only way to get an odd number when adding an even is if you have the other add-in as an odd number. The only way to get an odd number is to start with an odd number. So this is a variety of ways that we can look at patterns, that we can look at rules, we can generate patterns, we can look at patterns and see what we notice from them. All these different things are what math is based on. So now it's time for you to do your 3-column notes.